So let's look at some more examples of factoring completely. So number 4, I have 2y cubed minus 12y squared plus 18y. My first step is to factor out any GCFs that I have. And I see since these are all even numbers out in front, I know that 2 can go into all of these. And then I also see that they all share a y, and so that means I can also factor out a y. So my GCF here is 2y, and when I divide that out from each term, I get 2y cubed divided by 2y is y squared, 12 divided by 2 is 6, y squared divided by y is y, plus 18 divided by 2 is 9, and then y divided by y is 1. And so I see here I'm left with a trinomial. My a is equal to 1, and so that means I can use my shortcut here. So I'm looking for two numbers that multiply to 9, but then add to equal -6. Now since they're multiplying to a positive number and adding to a negative number, that means that all of my factors need to be negative. And so I have -1 times -9 gets me 9. And then -3 times -3 gets me 9. And I see the ones that add up to -6 are -3 plus -3. And so my answer becomes 2y, because again, remember your GCF needs to be out in the front, and then I have x minus 3 times x minus 3. Okay, let's try number 5. So number 5, I have 6x squared plus 15x. My first step is to check for a GCF, and I see I do have one. First, for 6 and 15, I see that 3 can go into both. And then for x squared and x, I see I can take out an x. And so my GCF is going to go out in the front. 6 divided by 3, I get 2. X squared divided by x, I get x. Plus 15 divided by 3 is 5. X divided by x is 1. And now I'm left with two terms here, but I see I no longer have a quadratic. There's no exponent of 2. And so that means that this is the furthest that this can be factored. So my answer is just 3x times 2x plus 5. Now looking at this last one, I have 4x squared plus 12x plus 9. So my first step is to look for a GCF. Here I have 4, 12, and 9. And since 1 and 4 are the only things that go into 4, and 4 doesn't go into 9, there aren't any number GCFs. And I see they don't all share an x, so this one does not have a GCF. And so looking at my chart, I see I have 3 terms. But this time I have a trinomial where my a is not equal to 1. My a is actually equal to 4 here. So that means I need to use the AC method. So AC method tells us I'm going to do 4 times 9 first to get me 36. And now I'm looking for two numbers that multiply to 36 but then add to 12. Since both of these are positive, that means that my factors are going to be positive. So I first have 1 times 36. 1 plus 36 doesn't equal 12, so it's not that. Then I have 2 times 18. Those don't add up to 12. And then I have 3 times 12. Nope. 4 times 9. That doesn't get me 12. And then last I have 6 and 6. And I see that 6 plus 6 does in fact get me to 12. And so that means I'm going to split my 12x into 6x plus 6x. I'm going to bring down my first term and bring down my last term. Now I can go ahead and factor by grouping. And so I see that my GCF for my first pair is 2x. My GCF of my second pair is 3. So factoring out 2x from my first pair, I have 2x times 4 divided by 2 is 2. X squared divided by x is x. 6 divided by 2 is 3. X divided by x is just 1. And then I'm going to do the same thing with the second pair. So my GCF of 3 is going to go out in the front. 6x divided by 3, I get 2x, plus 9 divided by 3, which is 3. And now I know I did it right because these binomials match. And so I can write this as 2x plus 3, which is just my GCFs going into their own parentheses, times 2x plus 3.